Hello, welcome back. Yeah, so I went to that, nice neighborhood restaurant and I came back. And yeah, I was ordered steak but in the restaurant slash bar I only eat salad and I take steak as to go box. Why? Oh, because uh, I wanted to like save it, steak and eat later. So that's why. This is a lot of food. So okay. Uh, so before I went there, I took a bath, of course, and I was thinking about this problem, and it occurred to me. Yeah, there's some important observation to make. All right, so uh, you have 71 and 73 here, right? They are twin primes. Okay, and then let's grab another whiteboard. Okay, so it's kind of important point. All right. Let's grab this guy. So, uh, it goes like this. Let's make this table a little bit longer, all right? Just a little bit. Now that I'm home, I can drink, but a little bit. Okay. So skip happens when the gap is not two. Okay, that's when this skip, this discontinuity in G1 set happens. G1 sequence. Okay. Yeah, because they are not twin primes, but they are cousin primes, right? Later on, yeah, Swazang primes. Okay, so when that happens, yeah, there's a skip, and you can always find for the cousin prime. Okay, we call it cousin prime. We call it 4 prime. Okay, and Swazang prime we call it 6 prime. All right, and twin prime, 2 prime. Okay, and A prime we call it octo prime. Okay, so octo prime pair where the distance between two adjacent primes when it's 8. Okay. Um, Twin primes, yeah, it's always continuous, right? In the G1 set, but for 4 prime, cousin prime, and Swazang prime and octo prime, they are also you can find this missing link like here. Okay, why? Because the gap, first 3 gaps are 2, right? Between primes, okay? 2, 2, 2. Okay, that's why up to octo prime, you can find the missing links directly underneath in that same column. Does that make sense? If not, don't worry about it. Why? We look at it the big table. Okay. And we made a big table, right? The gold box triangle, but um, we don't have to continue that fashion. We can make a partial table, partial triangle, okay, for some big prime number, okay, yeah, because we know the algorithm, right? Yeah. We will need to do that because we want to see some behavior, right? Um, okay. Yeah. Let's take 5 minutes break, okay? Because I'm being overheated with all this coat. Oh, it's hot. Let's take 5 minutes. All right. Whew. I am totally overheated. Okay. Yeah, I grabbed my notebook from my bed because it was on my bed. All right. Sleeping with my notebook. Okay, so that's kind of funny. Yeah, and Solomon said, like, yeah, when you learn good knowledge, when you learn, yeah, treat knowledge like as if it's your spouse. Okay. Yeah. All right. I ran out of a whiteboard. Okay, so all my whiteboard, 10 of them, is filled with this Goldbach. So unfortunately, we have to erase some. Okay, so what can I say? Ran out of space. So okay, now we'll do partial Goldbach number. Okay. Some big number. Okay, so it goes like this: dot dot dot. Then you have uh, 109. Next, no, 113. Next prime is 127. Okay, so yeah, big gap, 14. Okay, that's the prime gap. Let me double check. Uh-huh. 113, 127. Okay. Adjacent prime, and then the gap between is 14. All right. That's total, all right. So let's go ahead and construct Goldbach number out of these two primes. Okay. You add one, so 114, and then you add 2 from here, so 116. Add 2 from here again, so 118. And so add 1, add 2, add 2, add 2. Okay, so 120. And then add 4. Okay, so prime gap sequence. Okay, so 124. And let's expand this a little bit more. Okay, 13, 17, 19, 21, 23. Okay. Then add 2, 1 to 1 to 6, and add 4, 130, and on. Okay, so so, we actually need 109. So we don't need this guy. Dot dot dot. Dot 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 109. Okay. So we add 1, 110, 2, 1, 1, 2. 2 again, 1, 1, 4. 2 again, 1, 1, 6. Then add 4, 1, 20. And then add 2, 1 to 2, right? Very good. So, one, 2, 8. So we identified all the gap fillers, right? 116, 118, 120, 122, 124, 126. Okay? So yeah, sometimes you have to look back, but the question is, does it always exist? Or are there some holes? Can we always find gap fillers, the missing links, in the previous column? And that's not always the case, right? So how about the previous column? Can we always find it? Or how far should we look back? Okay? So that's our next question to answer. Let me drink a little, okay? So, it's been a long time since I drank. When was the last time I drank? I don't even know. Maybe this morning or afternoon. I don't know. It's Saturday, so I don't keep track of time. Alright, so okay. So why did 1, 2, 2 didn't exist in this column? It's because the prime gap sequence is like 2, 2, 2, and then 4. So that's why there's skipping within column. Okay? So that's why it didn't exist. Okay? What do I mean? I need green for prime gap. The gap between prime, okay? 2, 2, 2, and then 4. It suddenly jumps, right? Then 2, 4, 2, 4. Okay? So now we know why there is this skip within a column, just like there are skips within a row, right? Yeah. So when skip happens, it's because the gap is not 2, but it is 4, right? Between 7 and 11. Okay, that's why skip happens. Now the question is, can we find this vertically missing link in the previous column? Okay, so that's the question. Can we always find it? It's a very difficult question, all right? I guess the answer should depend on the gap between this column and the previous column, okay? So Well, let's add up some more numbers here. Okay. So that's 11 plus 109, 13 plus 109, and 17 plus 109. So we add 4, 1 to 6. Okay, so 90 plus 109, that's we add 2, so 1 to 8. And here 23 plus 109, yeah, add 4, so 132. And then we stop because our objective is to find the missing link between 114 and 128. All right, and as we go down, number gets bigger and bigger. So when it exceeds 128, we stop. Okay, so that's our algorithm. People verified Goldbach's conjecture for very big number using computers. Okay, so yeah, it's quite surprising why it works. Okay, there has to be a reason, right? There has to be a reason. So what do I mean by leading and lagging is this. 109, 113, 127, those are prime numbers, like far, far away. Fairly big prime numbers, okay? But, so horizontally it's leading, but vertically it's lagging because we are just starting from first prime, like 1, 3, 5, 7, 11, okay? It's very lagging behind, okay? So, that's what I mean, okay? So the gap, prime gaps, vertically, it start very small, like 2, 2, 2, 4, 2, 4, 2, okay? When the gap between these big prime numbers are fairly large, okay? So this concept of like filtering or sieving, right? Like Eratosthenes sieve. I heard, I mean, I've read some in this Goldbach conjecture context. Some people use the term sieve, sieving theory, whatever. Okay, so I don't know what that is, but uh, it's a very useful concept, it seems. Okay. So we know why 122 does not exist in this column because the gap, prime gap is 4, it's not 2, so that's why there we have discontinuity here, right? And my question is, why can we find 122 in the previous column? That's my question. Okay, let's take a break. Okay, so we'll take it nice and slow, right? So, all right. it is quite surprising it works. I mean, I'm still mystified by this gold box triangle. It's quite surprising. So, according to this calculation, okay, that I worked out, uh, this number 113 and 127, that's the very first occurrence where uh, the gap fillers can be only found not in 113 column but the previous column. Okay, we have to look at two columns. All the prime numbers, prime pairs before this, yeah, you can always find gap fillers in that column. You don't have to look any other columns. Okay, so this is the simplest example there is when gap fillers cannot be found in one column. You have to look at two columns. I'm still mystified. Okay, so because to me it's surprising that this previous column has 1 to 2. That's I'm sure later on, bigger prime numbers, you probably have to look at 3 columns to find all the gap fillers. What am I talking about? 1 to 2, that's even number, right? We want to find the Goldbach pair of primes, Goldbach pairs. 1 to 2 is 109 plus 13. Those are the Goldbach pairs for 1 to 2. Okay? It is surprising Goldbach's conjecture actually works. It's surprising, okay? And there has to be a reason why it's working. Okay. So the gap here, I mean the skip happens because the prime gap here is 4, right? It's not 2, 2, 2, but 2, 2, 2, 4. Okay. Let's just pretend that uh, 111 is a prime number, okay? Let's just pretend 111 is a prime number, okay? We have 111, so then Goldbach kind of false. 4 Goldbach number would be 112, 114, 116, 118. So 2, 2, 2, 4. 1, 2, 2. Okay, okay. So it can be found in there too. Okay. Uh, how 107? Let's pretend 107 is a prime number. Okay. Is 107 prime number? I don't know. Let me look. It is prime number. Okay, okay, whatever. 108, 222, 110, 112, 222. One more time. 114 and 4. 118 and then 2 again. 120 and then 4. 124. Yeah, so 122 does not exist. Okay, so this is a very difficult problem. Okay. It's as if we're just lucky to have 1 to 2 in the previous column. As if. Oh. Wow. Very difficult problem. It's amazing because this works. I mean, that was just to amaze me. By far the most difficult mathematics problem I've ever faced so far. So gap between Goldbach number, we call it Goldbach gap. Okay. As opposed to prime gap. Okay. Uh, when Goldbach gap is 4. Uh, Okay. Alright. Yeah, I'm looking at that gigantic whiteboard. I mean, the big table. Yeah, there is pattern there. Identifiable pattern. Okay, so okay. Let's step back. All right. Let's look at that big table. All right. Okay. Um. Yeah. Okay. All right. So the pattern is this diagonal matching. All right. If prime gap is 6, right? You one red line. Prime gap is 6. Okay. Yeah. Our Swazang number. The diagonal look always is the same. Like red, blue, 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 red, blue, 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 blue. Okay. When prime gap is 4, yeah, cousin primes, right? Yeah, it's always like this: blue, blue, green, green, blue, blue, green, 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 blue, blue, green, green, green. Okay. So that's the pattern, repeating pattern. Okay. So when prime gap is 2, it's like green, 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 green. Okay. Green, 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 green. Yeah, it's exactly the same. All right. So and look at let's look at this way. Okay. We have 90, 90, 90, 90, 90, 90, 90, 90, 90, 90. Okay. So some numbers do repeat itself all the way through, and some numbers don't. Okay, you have 62, 62, and there's no 62 in these two columns. And then you have 62 here, and then over here. So 62, it kind of skips two columns basically. Okay, kinda. Some numbers like 90 is found everywhere. It's continuous. And some numbers don't behave like that. You 64, 64, 64, 64, then you skip one column and 64 again, and then it disappears. Okay. Yeah. How interesting. Okay, let's deal with some smaller number. Okay, so this fifth Goldbach triangle should contain, if Goldbach conjecture is true, this fifth Goldbach triangle should contain uh, even numbers from 2 to 12. Let's see. 2, 4, 6, 8, 10, then 12. I want to see some trajectory, okay? So how about all the way to 29 and 28? Okay. 2, 4, 6, 8, 10, 12, 14, 16, 18, and then 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, like that. Okay? Okay. Plot thickens, really. Wow. No wonder nobody solved this. I mean, except presumably, supposedly, possibly, Professor Pogorzelski. And no wonder he dedicated his life to solving this problem because it's a very interesting problem. But and it's kind of addictive too. All right, so yeah, I'm trying to understand this pattern. All right, why it's happening like this. Oh, okay. Beats me, really. I'm looking at the other whiteboard, okay, so. Mhm. In prime number theory, some people use like calculus, right, and even polynomials, like Riemann zeta function approach, and some people use like statistical method, like Gaussian normal distribution. Okay, so yeah, it's just interesting approach, but I don't know any of that. Okay, I mean, I don't have time to study all those things, so. Let's see what happens when prime gap number is 10. it's kind of interesting. Okay, so prime number gap is like 1, 2, 2. I mean, two, in our convention, 2, 2, 2, 4, 2, 4, 2, then 6, then comes 8, and then comes later on comes 14, 8, and then 8, 4, 2, 4, 2, 4, then 14. Later on appears 10, and later on appears 12. So it kind of jumps like that. Ooh. Tough cookie, really. Prime gap sequence, okay, it's tough cookie. Yeah, I'm just looking at Wikipedia here. Well, I naively thought that we might be able to prove this over this weekend, but it seems that's not the case. Alright. Uh, it's very hard not to crack. Oh well. Oh, I don't know about you, but I can use some sleep. Alright, so I sleep on this. Okay, I promise. Probably what we will need, okay, is that we gotta work out some examples where the prime gap is 10 or 12, and work out the gap fillers. Okay? Because I have this Wikipedia and it tells me where 10 occurs. Okay? Prime gap 10, 12. We have to look at that. Okay? Yeah. And we construct a partial gold bar triangle for those primes. Okay? And then see how farther back do we need to look to find the gap filler numbers. Okay? We'll do that tomorrow. Alright? Now I'm kind of sleepy. Alright? Yeah. Yeah. My eyes are too heavy. Okay, so. Okay? Yeah. Yeah, we Asians, we tend to have very small eyes, but still, it can get very heavy. Okay. So. Thank you. I'll see you tomorrow. Bye.